welcome back. In this recording, we'll continue chapter 4, basic types, operators, and expression. We have covered in the first part the simple types, integer types like char, short, int long, and long long. Then we have covered the unsigned ones, and then the real types of variables. Then we have shown how we can declare simple variables and and then we have tackled the constant, the integer constant, the automatic type, the force type, and then we have seen also that we can express integer constants in either octal and hexadecimal bases. Then we have covered the rational constant also in their normal form and forced ones, and the constant characters. And we have said that we use these constants while initializing the variables. Then we have covered the operators in C, the known operators like the arithmetic ones, logical operators, comparison operators, and logical ones. And we have some particular operators in C like the assignment operators and the plus plus and minus minus. So we have reached that far in the previous video. So today we'll continue from part 4.4. So it's on page 36 in the book. So today we'll talk about expressions and instructions. So how we have seen already instructions. So instructions are sentences that ends with a semicolon. However, before we can say how we construct instructions, we need to know what is an expression. So usually an expression is defined by recurrence. It means that recursively we can try to form an expression. So constants and variables are considered as expressions, and the expression can be combined with each other using operators. For example, I can, if I am using here a variable x, and there are two variables x and y, I can link it together, x plus y, and they will be considered as an expressions. And expression can contain functions call, and they can also appear in parameters. So we need just to wait a little bit about functions, as we'll cover it later in this chapter. So here are examples of expression. For example, I equal to 0 is an expression. I plus plus is equal to 0. X equal power a 4. It means that I will raise a to the power of 4. Printf hello with the backslash n is an expression, as well as the last three. So in order to transform an expression into an instruction, we just need to add a semicolon at the end of an instruction. So here it is. So just need to add a semicolon. So in in C, every instruction return a value. For example, 3 plus 2 equal to 5. It returns a value. It means that 3 plus 2, it will be evaluated to 5, and we'll check whether 5 is equal to 5. So I remind you that a double equal is a conditional. It means whether 5 is equal to 5. However, one single equal, it means assignation. It's equivalent to the arrow that we have used in the first semester. So when we say A equal 5 plus 3, it means we will put 5 plus 3 in A, and the result will be 8. So in assignments, since assignments are also interpreted as expressions, so we can take advantage of this one. So we will put the sign of x in A, and then we will compare it with 0.5. So this is just an idea on how we can transform an expression into an instruction. So let's see now about the order priorities. So we know already in mathematics that if we have an expression like 2 multiple 3 plus 2, so first we will evaluate the multiplication, and then we will add the plus, even if we have something like this. So first we will evaluate the multiplication, and then we will evaluate the plus. So let's take an example, and then we'll see how the operator priorities works in C. So suppose we have an example here that there's a 5 in A, 10 in B, and 1 in C, and we have the following. Now we call it instruction. Why? Because it's an expression and it ends with a semicolon, so it's an instruction. So how the computer will work? So first, the computer will see that we should evaluate 2 multiple A. So 2 multiple A, and in A we have 5. So it will have 10 here, and then he will to evaluate 3 multiple B. So in B we have 10, 3 multiple 10, so it will give us 30. 4 multiple C, and in C we have 1, so we'll have 4. And then he will do the summation, and he will end up with 44, and then he will assign the value 44 to the value of x. So 44, it will be put in the variable x. So we know already that the multiplication has priority over addition, and that multiplication and addition have priority over assignment. So if you want to force the computer to do other types of priorities, so as you know, we should use brackets or parentheses. So here is the example again. However, here we have used brackets here. So obviously we need to do the summation first. So we do a plus 3, then we multiply by 2, and then we multiply by the value of b, which was equal to 10, and then we add for multiple c. So let's do it on the side here. So it's 2 multiple. In A we have 5 plus 3 multiple. In B we have 10. So first we do this. It's equal to 8. Then we multiply 2 multiple 8 multiple 10. So it's equal to 160. And then we'll add plus 4 multiple 1. At the end, we will have 164. So 164, the value will be assigned to the value of x. So we will put 164 in the value of x. So this is just a very simple example. However, in C, we have multiple operators, and thus we have multiple priority. So the strongest is here in the top of this table, and the weakest one are at the bottom. So whenever we have a bracket, sorry, we should evaluate what's inside bracket first, and then we should move to the unary operators, not plus plus minus minus, then multiplication, division, and the remainder, and then we will pass to the plus and minus. Then the comparison one, less than or equal, greater or than. Then we will pass to the equality or inequality test, and then for the logical and, logical or, and at the end the assignment operator. So if, for example, in the next slide, there's a rule for the evaluation. So we have sometimes these two arrows. So if we have, for example, an expression, example, x multiple y multiple z. So we have two multiplications. So how do we perform the multiplication? Do we first do this one or this one? So it is said that if you have an operator in the same class, for example, if you are here and we have an expression having those operators, so we evaluate from left to right. So we use this arrow if you have operators in the same class. However, for unary operators and for assignment operators, we evaluate from right to left. So in this category and in this category, we evaluate from right to left. However, in all the other categories, we evaluate from left to right. So we will give examples. So let's see here. So we have here an expression. It's not an instruction because it's not ended with a semicolon, and we have plus or minus. So all the operators here belongs to the same priority, which is 4, and since it's not an operator nor an assignment, so we evaluate the expression from left to right. So first we evaluate 10 plus 20, it will give us 30. 30 we will add it to 30, it will give us 30. 60, and 60 minus 40, it will give us 20. 20 we add 50, so it's 70. 70 we subtract 60, we end with a 10. So this is a very simple example. let's now move to a more complex one. So here also we have an expression, we have the assignation assignment operator. So let's go back to the operator properties. So it's here, and as I have said, the unary operators and the assignment operators, we usually work from right to left. So let's start. So we will start like this. So first we evaluate b plus equal 5, and we know that b plus equal to 5 is equivalent to b equal b plus 5. In b we have 4, so we have 4 plus 5, so in b we'll have the value of 9. So now we have the expression that looks like this: a multiple equal to 9. So again, this one is equivalent to a multiple 9. In a we have 3. 3 multiple 9 is equal to 27, and we assign 27 to the value of a. More complex example, we have this expression. So as I've said, let's go back. The unary operators here, as we have seen in the assignment, the evaluation starts from the right to the left. So let's go back to the example and see what kind of operator do we have. We have the exclamation one, the not, we have the minus minus, we have the plus plus, and we have the equal equal. So let's go back and see the priorities. So the exclamation mark, the plus plus and minus minus are more, they are stronger than the equal equal here. So first we should evaluate the exclamation mark, the plus plus and minus minus, and then we should evaluate the double equality. So we have this one and this one. So we can either start with the exclamation mark minus a, or by the plus plus not b. So in the not a, so those one are unary operators, and as we have said, we should start from the right to the left. So first we apply minus minus I. So minus minus I, it's a pre-decrementation. So we decrement a. So a is equal to 1, and then a will be equal to 0. Then we will apply not. So not 0, it means what? It means it equal to 1. So we have not minus minus a is equal to 1. Now we will move to plus plus not b. In plus plus not b, again we have two unary operators. We evaluate the expression from right to left. So b is equal to 4. b, not something equal to 0. It means not false. This one will evaluate to true, because everything different than 0 is considered true in C. So 4 is different than 0, so it's true. Not true is equal to false. False in C is equal to 0. Then I will apply the pre-incrementation operator. So plus plus 0, it means it's equal to 1. So I have evaluated plus plus not b, and then I will check. So I reminder, this is the equality test. So it checks whether the two parts are equal. So does 1 equal to 1? So yes, in C it means 1. So the answer, the value that returns this expression is 1. So to avoid confusion, sometimes we can use brackets. So I have parentheses. For example, in this example, however, as I've mentioned before, you should pay attention to the assignment operators. So as I've said, there's like fictive brackets here, and whenever you convert this, so this one is true, this one is false. So when I have assignment operator, so everything on the right side will be multiplied by the value on the left side. So this is wrong and this is right. So make sure to pay attention on these subjects. So we'll have an exercise here. So we need to evaluate the following expression, knowing that a is equal to 20, b is equal to 5, c is equal to minus 10, d equal to 2, x equal to 12, and y equal to 15. So they are asking us to note each time the value rendered as a result of the expression and the value of the variables whose content changed. So we need to give the answer, and if a variable, the content of a variable has changed, we should say the new value. We should know the newest value. So let's start. I will not do all the exercises. I will pick some of these. So let's do the first one. We have 5 multiple x plus 2 multiple 3 multiple b plus 4. So as we have seen as in the priority table, first I should evaluate the brackets. So when we have multiple brackets, we start from the left to the right. So first I will evaluate 5 multiple x. So x is equal to 12. 5 multiple 12 is equal to 60. And then I will keep those, and then I will evaluate this one. In order to evaluate this brackets, I need to evaluate 3 multiple b. So b is equal to 5. 3 multiple 5 is equal to 15, and then I will add 4. Now I can evaluate also the brackets. So it's 60 plus 2 multiple 15 plus 4 is equal to 19. So 2 multiple 19 is equal to 38, and 60 plus 38, so it will be equal to 98. So the value of this expression is 98, and none of the variable x and b got their value changed. As for the second example, I will let you do the computation. At the end, you will have the value 1890. So let's do the third expression. We have a equal b equal to 5. So first, we evaluate what's in the bracket. So a, does it equal b equal to 5? What does it mean b equal to 5? I will put 5 in b. So it will remain 5 here. Does a equal to 5? So there's in a there's 20, and does 20 equal to 5? Of course not. So the result will be 0. And in b we have changed the value of b. It was 5 and it remained 5. So let's do the fourth one. We have a plus equal x plus 5. So again, first we do what's inside the bracket. So indirectly we'll have a plus equal. So in x we have 12. 12 plus 5 equal to 17. And this one is equivalent to a equal a plus 17. In a we have 20 plus 17. So we will have the value 37. So in a we will have a new value which is equal to 37. The fifth one, we have a not equal to c multiple equal minus d. So again, we will do first what's inside the brackets. So a different than c multiple equal minus d. So in d we have 2, so it will be minus 2. So again, we will do what's inside the brackets. So a different than c equal minus 2. It's equivalent to c equal c multiple minus 2. So it's c equal c multiple minus 2. So c multiple 2 minus 10 multiple minus 2. So c will be equal to 20. And then we will have here a, is it different to 20? Let's see. A, is it different to 20? So in a there's a 20, and so a is not different than 20, so the result will be false. It means 0. Let's move to the sixth ones. A multiple c plus x minus d. So again, we will do what's inside the brackets. So c plus x minus d. So in x we have 12, and d is equal to 2. So 12 minus 2 it's 10. So C plus 10, and in C we have minus 10. So it will be equivalent to A multiple equal to 0. This means that in A I should put A multiple 0. So at the end, A, there's 20, and 20 multiple 0 equal to 0. So at the end, the value is 0, and the value of A will be changed to 0, since we have put 0 in A. Let's do the following. A modulo equal D plus plus. So we have here modulo equal and plus plus. So if you remember in the table, plus plus is more powerful than modulo equal. So first we evaluate the D plus plus, and then we evaluate the modulo equal. And as you remember, D plus plus is a post incrementation. So what does it mean? So I will later on do the addition. So first we will do A modulo equal D, and then at a later stage we will do the D plus plus. So this one, it will be equivalent to A equal A modulo D. So in A we have 20 modulo D, which is 2. What's the remainder of 20 over 2? The remainder would be equal to 0, because 2 divides completely 20. So we will have 0. So the result is 0, and in A we will have 0. Then we will evaluate the D plus plus. So in D we have 2. Later on we will have D equal to 3. Let's do the 8. A modulo equal plus plus D. So here again in the priority table we have to do the plus plus, then the modulo equal. We have here a pre-incrementation. So before doing the modulo we should do the plus plus D. So first we'll do the plus plus D. So in D we have 2. We end up with D equal to 3. And then we will do A modulo equal to 3, which is equivalent to A equal A modulo 3. So in A we have 20 modulo 3, so it's equal to 2, because 6 multiple 3, no, it's equal 24, so it's 5. 6 multiple 3 equal 18, so we'll have 2. So A will be equal to 2, so the value of A here will be equal to 2. So exercise 9, part 9, we have x plus plus multiple A plus C. So again here we have plus, we have multiplication, we have double plus, and we have the bracket. So first we evaluate what's inside the first bracket. In the first bracket we have x plus plus. X plus plus is a post incrementation, so I will do it later on. So as if here I have x, which is equal to 12, and a later stage I will increment x and it will be 13. Multiple, we have here A plus C. So in A we have 20, and in C plus minus 10, which is equal to 10. So 12 multiple 10, we will have at the end 120, and the value of x is modified to 13 here. 10, A equal x multiple B less than C plus y multiply by not B less than C. So we have the brackets, we have multiplication, we have the sum, and we have the comparison operator. So if we come back to the table of priorities, so we have the not, we have the operators, comparison operator here, and we have the multiplication here. So again, we'll start first with what's in the bracket. So in the bracket here we have B less than C. Is B less than C? Let's check. 5, is 5 less than minus 10? It's wrong. So in A we will have x multiple 0 plus y multiplied by not. Is B less than C? Again is 0. So x multiple 0 is 0, not 0, not 0, not false, it means true. So this one will be equal to 1. So a equal y multiple 1. So in a, I will put y, which is equal to 15. So at the end, I have a equal 15. 11, not x minus d plus c or d. Again, we have the not. The unary operators, we have the or, which is a comparison, which is in the lowest part of the table. So first we'll evaluate what's inside the bracket. So it's not. In x, we have 12. 12 minus d, 12 minus 2 equal 10. 10 plus minus 10. So we have here 0. 0 or d, which equal to 2. So not 0, not false, it means true. 1 or 2, true or true, it means it's true. 12, we have A and B, or not 0 and C and not D. So again, here we have just we have the unary operators, which we evaluate from right to left, and we have the comparison operators, the logical operators, which we evaluate from left to right. So here, not 0, not false, it means 1. Not D, in D we have 2. 2, it means true. Not true, it means false. So we have A and B. I rewrite it. A and B, or 1 and C and 0. So if you go back to the table, and we have and or, first we evaluate and then we will evaluate or. So this one, we know that from mathematics, or is more powerful and is more powerful than or. So we have A and B. So in A we have 20, which is not 0, so it's true. B is equal to 5, again it's not 0, so true and true, it means true. So here, true, it means 1. I have or, so or it remains with us. We have 1 and C and 0. 1 and C and 0, it means 0, because 1 and minus 10, 1 and 0, 0. 1 or 0, it's equal to 1, which means it is equal to true. So let's do the third thing. We have A and B between brackets, or and not 0 and C, and minus not D. So we have used brackets here. So at the end we will have 1 or 1 and 0, which will lead to 0. You can check it by yourself, and here again we have 1 or 1 and 1 and 0, which is equal to 0. So it's a nice practice to work on this. So in order to know the priorities and how you can mix all these together. So let's talk about the standard arithmetic functions. So in math, we use functions like logarithm, sine, cosine, square root. So all these functions, they were written already, like the function printf was written in the library, which is called stdio. We have a library called math.h, which contains all the implementation of these functions. So you should know that all the arguments, the variables that we use in these functions are of double type. So let's check the functions now. We have the exponential function. So we just give a variable here in order to get the exponential. We usually use a lot the power. So whenever we have x power y, we use power x y. We use also the square root, and sometimes ceiling at the floor, the round ls, the ceiling round up, and the sine and cosine function. So we will work on an example in a while that will use all these examples. So we have here an exercise. I will not do it here directly, because I will make a special dedicated video for this exercise, since we'll be working directly on a compiler, not using slides. So they were asking us just to use this code. This code, it reads two values, a and b, and then it calculates the square of a and the square of b. So they are asking us to reuse this program in order to calculate a power b, to calculate the hypotenuse of the right triangle of sides a and b, the tangent, the rounded value of minus of a over b, and the rounded values into 3 positions behind the comma of a over b. So I will cover it in dedicated recording of this exercise. So what we need to do if we need to convert types. So as we have seen, we have a lot of types in C. We have the natural types, the int, char, long, short, and long. We have the unsigned variations, and we have the real types, which are the float double and long double. So one of the questions arises is what we have to do when we have multiple types in a single expression or instruction. So how does it operate? So for this, we have to take into account that some automatic conversion occurs, and sometimes the programmer forces the operations and the conversion by using casting. So we'll cover these two aspects. So as we know, if we have an operation that contains variables of different types, so the higher types will dominate, so automatically it will be a conversion to the higher types. So let's take an example. For example, here we have 3 variables: the I, which is an integer and initialized to the constant a float x, which is initialized to the real constant 12.5, and a double, which is y. So, and we have the instruction here: y equal I multiple x. So I is an integer, x is float, and y is double. So while in the multiplication, and as we have seen, while evaluating this operation, first we do the multiplication and then we do the assignation, the equal. So first we have an integer multiplied by a float. So float is more powerful than int. So I will be converted first to float. The result of the operation will be assigned to y. Y is double, so also the result will be transformed into a double in order to be stored in y. So we have here 2 conversions. First, the I is converted from int to float, and then the result of the multiplication, which is a float, will be converted to a double. Let's take here an example. For example, in power, and as I have said in just earlier now, that all the functions in the math.h, including power, they need the variables of type double. So here we have a equal to 200 and the variable result, which is all are integer. And so 2 here, it will need to be converted to double. A, it will need to be converted to double. So we have now 2 conversions. The value returned by power also is a double. So when we have a double, we should put the double in result in res. Res is an integer, so we would force this operation from double to int. So here we have 3 conversions. 2 is converted to double, a is converted to double. The result of power, which is double, should be converted to the assignment type, which is res. So res here is an integer, so double should be converted into integer. So we have here the rules for the automatic conversion. So if we have 2 integer, for example, the char and short usually are converted into integer, and then the computer will choose the large of the 2 types. So first, he will if you have integer unsigned int long or unsigned long, it will choose the biggest one. If we have an integer and a rational in the expression, so usually we will take the rational type. If we have 2 rational, we will take the biggest one, knowing that long double is bigger than double and double is bigger than float. For the assignment and assignment operator, the result is always converted into the type of the destination. For example, as we have seen in the previous slide, we have the type was weaker, so we have loss of precision. So here the result was power, and we have to convert it, the result of power, which is double, to an integer. So usually we lose some precision in this. So let's take also an example. So we have here 3 variables: int x, float a, and char b. We have the operation xa over b. So again, here we have a division and we have an equality, the assignment, sorry. So first we do the division, and then we will assign the value of a over b. So a over b, a is float and b is char. So the power of 1 is float, so we will convert b from char to float. So at the end we will have float over float. The result will be of type float, and then we need to assign a float to x which is an integer. So we will downgrade the float 1 to an integer, because as in the first rule we are obliged to convert the type of the expression to the type of the variable on the left, which is the type of the assignment. So again, let's take an example. So we have here 1, 2, 3, 4, 5, 6 variables, a, b, c, d, e, f. So a is char, b is int, c is float, d, e are floats, and f is a char. So let's see the expressions here, the expression a over c, a over b, a over c. So we have here a of type char and c of type float. So char eventually will be converted to float. Float over float is a float. However, d is a float, so there's nothing lost. So the result is a float and will be stored in a float. So in the example above, d will have a value equal to 0.75. In this one, we have a is a char, b is an integer. So as the first rule, we will convert it to the more powerful one. So char will be converted to int over int. So let's take the example here. We have in a equal to 3. We will divide it by b, which is equal to 4. So it will be equal to 0 point something, and we have an integer here. The result should be an integer, so the result will be equal to 0. We will drop what's above the comma. So this is the integer. So the value of 3 over 4 now is equal to 0, and then I will assign it to e. E is of type float, so I will convert 0 to float, so it will be equal to 0.0. So pay attention to those stuff. When we divide two integers, the result will be an integer. A over c. So again here, a is a char, c is float, so a will be converted to float. Float over float, it will be a float. However, I will put, so a over c would be equal to 0.75 here, because the value is of float type. And then I will put in f. F is of type char. So char, it's an integer type. So I will drop the 0.75 and we will store in f the value of 0. So it's very important to pay attention to those stuff in order to get the correct answer. So how can we solve this problem? This is one of the biggest problem in C. So if you have two integers, two variables of type integers, and do the division, we will end up with incorrect results. So in order to do that, we need to change one of the types of these variables. However, the variables are already declared. So one solution is to do the, so let's come back and we will work on the first type, and then we'll do this exercises. So one way to do that is to use what's called casting. So I will force the expression to have another type. So let's see the example here. We have a over b. A is of type char and b is of type int. So a is equal to 3 and b is equal to 4. So again, this one is integer, will be converted to integer, and this one is an integer. So the result will be an integer, so it will be equal to 0. So in order to remedy, we will use casting, force casting. It means that we will force the type of the variable. So here a is no more integer, we will force it to be of type float. So what does it mean? It means that now the value of a will remain of type character, but however the value that we will use in this expression will be considered as a float. So 3.0, this one is no more integer, so it's a float now. So float over integer, so this one will be converted to float since float is more powerful, and we will end up with the value of 0.75. So by forcing, we mean that we in the calculation, in the expression, we have forced the type of a variable to change. So in order to force, we just use brackets here and we put the type that we want to force the expression to be converted to. So let's come back to examples. We have here an exercise. So we have three variables: long a equal to 15, long char b equal to a, and long short c equal to 10. So we have the expression. They are asking us to give the type and the value. So we have the first one, c plus 3. So if we have expression c plus 3, what's the type of the expression? So we have short c of type short, so eventually the type will be short and the value will be equal to 13. b plus 1, we have a character b, so what the type could be. So we have here b, so it could be either a char if I want to consider it as a character, or it would be an int. So if I consider it as a char, so if I have the character a, what's the next character after a? So it would be b. And if I'll consider it as an integer, so 65 plus 1 would be equal to 66. We have c plus c, c plus c, so the type would be equal to short, and c plus c would be equal to 20. If you want to apply the rules, you can also say it could be converted to integer. 3 multiple c plus 2 multiple b, we have here short plus char, so eventually it will all be converted to integer, and the value would be equal to 160. So 5, 2 multiple b plus a multiple 10 over c. So we have here long, char, and short. The strongest one is long. So we have 2 multiple b, 2 multiple 65, plus 2 multiple 65, plus a, which is equal to 15, plus 10 over 10. So just to make clear here, so 15 plus 10 is equal to 25, 25 over 10, so 25 over 10. So let's write it like this, 25 over 10. In C, since both are two integers, is equal to 2. Not 2.5, it's just equal to 2 because the division of an integer over an integer is an integer. So we will end up with a value of 130 plus 2, so it's 132. So the difference here is one of the operands are of type double, because there's it's a real number. So we have b, we have here the calculation a of type long, and we have a number of type double, so a automatically will be converted to type double, and thus all the calculation will be in double. So we have here 2 multiple 65 plus 15 plus 10.0 over 10. So here 15 plus 10.0 is equal 25.0 over 10. So we have here a double, we have here an integer, so here it will be converted to double, and then we will have the value 2.5. So we will be adding an integer to a double, so the value would be a double, so it will be equal to 132.5. So what's the purpose of this exercise is that whenever we have a calculation that involves only integer, and when we have especially division, we should make sure that one of the operands is of type double, float, or long double. So in order to do that, we have two solutions, or we can add 0.0 to one of the numbers, or we can multiply by 1.0, or we can use decasting as we have seen here. So this is done for this chapter, and so I will make a new video for the exercise. So if you have any questions, do not hesitate to send it to me, and do not forget to hit the red subscribe button and to hit the bell icon to turn on notifications. So till the next chapter, stay safe and have a nice week.